Hello everyone, I'm Akila Belgula. Today I'm going to explain about the classifiers in the machine learning. This presentation focused on the popular classifiers used in the real world tasks. You learn how they work, the strengths and where to use them. Classifiers are the part of the super learning. So let's start. What is classifiers? A classifier is nothing but is it? It is an algorithm that assigns input data to class or label. It's learned from the label training data to make future predictions. Classifiers helps with the decision making task in the AI system. For example, if you have to include the spam detection, decision classification, and the digit recognition. If you want to input a photo of the digit, it predicts of it's a 2 or 5 or 9. It uses in a mathematical models to learn patterns in the data, and the classifiers are the central to your supervised learning problems. They give categorical outputs, not continuous out. And then why do we need a classifier? Why do we need a classifier means how human analysis becomes difficult when data grows large. Classifiers automate decisions with the speed and accuracy, and then they detect the patterns that might miss. It's useful in the tasks like image recognition, spam filtering, and the fraud detections. It's helpful in the medical AI systems also. It can predict the decisions based on the symptoms. It helps in sorting, grouping, and filtering in a large data sets. It ensures the consistent and repeatable and unbiased decision making. And it classifies the reduce the manual work in the real time systems. And then types of the classifiers. There are the three types of the classifiers in the classification. First one is the binary classification, and then multi-class classification, and then multi-label classification. Binary classification is nothing but in this we have the two output. For example, pass or fail. Multi binary classification is the simplest classification. It is used in the basic prediction task. And then classification. In this, we have more than two outputs. For example, 0 to 9 digits. Multi-class classification is a common in the large image. For example, large image, for example, such that image, text, object recognition. And then multi-level is nothing but useful for the tagging or a document and a categorization exam. For example, in this for example, one input, multi-labels are the actions plus comedy. Choose the type of based on your problem and data set. In each classification types need a different evaluation. And then popular classifiers overview. In this we have seven types of algorithms are there. First one is the logistic regression. Logistic regression is nothing but it is a very simplest and it's very fast and it is used for the binary problems. And then decision tree. Decision tree is nothing but a rule based. It's visual, rule based and the visual, and it is very good for the interpretation. And then random forest. Random forest is used for the used for the problem statement in a classification. It is both used for regression and a classification. And then it's a group of decision trees. It reduces the overfitting. And the SVM is nothing but the support vector mission. Support vector mission is supervised machine learning. It uses both classification and regression. It's find the best boundary between the classes. In the It's have the hyperlength. And then KN is nothing but the k-nearest neighbor. It's based on the probability, and it's great for the text classification. And then neural networks. Neural networks is nothing but they handle the big complex data. It's very used during a deep learning. Uh, Logistic regression and a decision tree. Logistic regression is nothing but it works. It is a supervised learning. It is works well for the binary classification task. It computes the probability of a class using the sigmoid function. It is a sigmoid function. It is the S-shaped curve, and it interpretable and quick to train. And the decision tree is nothing but a bullet tree like structure of decision rules, and each node split the data based on the futures and easy to visualize and understand, and it can lead to overfitting and unless pruned. And then random forest and SVM. Random forest is nothing but a supervised learning. It combines the multiple decision trees ensemble model. It's nothing but a ensemble model, and it's used in majority voting for final predictions, and it's more robust and less overfitting than single tree. And then SVM. Yeah, SVM super vector mission. It's find the best separated boundary effective for the high dimensional data, and it works well in the high dimensional spaces, and it can used in the kernel trees for the non-linear separation, and it's good for both binary and multi-class classification. This is the hyperlink, this is the positive margin, and this is the negative margin. These are the support vectors between the vector between the two classes. These two vectors are between them hyperlink. And then kernel. Canaan is nothing but a k-nearest neighbor. Already no, we already know it's based on the closest neighbor. It is based on the closest neighbors. Simple but slower on big data. It's lazy learning algorithm. It shows the all training data. It classifies the based on the majority label of the near points, and it is very simple and effective. But it's slow on the large data sets. And then naive Bayes. Naive Bayes is nothing but it's a base theorem and a conditional probability. It assumes the futures are independent naive assumptions, and it's very fast, and especially for the text-based data like emails. Uh, and it performs the super well, and even with the simple assumptions. And then neural networks. Neural networks is nothing but it inspired by the structure of the human brains. It's composed of the layers input, hidden, and output. It's learn the complex and non-linear patterns in the large data, and it's very used in the deep learning, comma, image, audio, text recognition, and can model very high dimensional problems and requires a large data set and compute the power. And its neural networks and outperforms the traditional models on many tasks, and it is used in the self-driving cars and the facial recognition and the more etc. And then metrics, and then evaluating the classifiers. In this we have metrics, accuracy, and a precision, and a recall, and an F1 score, and a confusion matrix helps the visualization performs. And in this we have you must evaluate the model performs using the metrics. First one is the accuracy. Accuracy is nothing but it's correct the predictions out of total predictions. And then precision, and the precision is how many predicted positives are actually correct. And then recall, and the recall is nothing but the how many actual positives were corrected found. And then F1 score. F1 score is a harmonic mean of precision and a recall. And then confusion matrix, it's a visual tool for the classification results. It helps to detect the class imbalance or predictions errors, and its evaluations the ensures your model in a reliable. And then applications of the classifiers. In these classifiers are used in the near every AI system. In healthcare, decision diagnosis from the symptoms are image. In email, spam detection and protection. And in finance, credit scoring and fraud detection. In social media, content moderation and recommendation. In detail, customer segmentation and product suggestions. In law enforcement, face or license plate recognition. Classifiers drive the decision making in the smart system, and the fraud detections also it's very powerful. And then finally conclusion. And finally, I have to conclude that the classifiers are the essential tools in the supervision learning, and they may inputs to the specific output classes accurately. The choice of the algorithm depends on the data type, size and use case, and it's no one model fit all, and experiment and evaluate, and it's continuously testing and ensures the better predictions over time. It's understanding and the model behavior. It's keys for the trust and fairness, and it classifies power intelligence and systems in every field today, and it mastering them to essential for any model any ML developers. Finally, thank you.